All right, let's get right into it. We usually think that making AI smarter is all about throwing more and more data at it. A bigger data set equals a better model, right? But what if the real secret isn't about training harder, but about training smarter? Today, we're diving into this really cool new approach that's all about teaching AI by carefully picking out the perfect lesson at every single step. And this really gets to the heart of the problem. Modern AIs are learning from these massive internet-scale data sets. I mean, it's literally a fire hose of information blasting at them constantly. So the real challenge is, how do you sort through all that noise to find the actual signal? How do you give the model exactly what it needs to learn without just completely overwhelming it? Because as it turns out, just dumping all the data on the model is a pretty bad idea. For one, it's incredibly slow and super expensive in terms of computing power. But honestly, that's not even the worst part. It can actually hurt the AI's performance. The model can get confused by noisy or redundant info, which leads to this wild thing called catastrophic forgetting, where it literally starts forgetting stuff it had already mastered. Now, researchers have known this is an issue for a while, and they've definitely tried to solve it. But the old way of thinking, which was basically just about ranking data, it has some pretty serious flaws. Let's take a look at why it just doesn't cut it. So, the classic method is something called gradient-based selection. And the idea on the surface makes a lot of sense. You look at every single piece of data, figure out how much it's going to change the model, that's its gradient, and then you just rank them and pick the ones with the biggest impact. Sounds logical, right? Well, yeah, but it's not that simple, and this is where it all starts to fall apart. For starters, this method totally ignores the optimizer, the algorithm like Adam that's actually in charge of updating the model. The optimizer has its own memory and its own way of doing things, and if you ignore it, you're missing a huge piece of the puzzle. Second, it's blind to redundancy. It might pick 5 amazing, high-impact pictures of a golden retriever, but the AI probably only needed 1 to get the point. And finally, it was really built for this old-school, offline style of training, not the fast-paced, on-the-fly learning that modern AI is all about. And this brings us to the big idea at the heart of this research. It's a total shift in how to think about this problem. Instead of just ranking data, the new idea is to be optimizer-aware. And this quote from the paper just nails it. The goal isn't static sample ranking anymore. No way. The goal now is to actively shape the AI's next lesson, knowing exactly how the optimizer is going to react and use that information. It's so much more dynamic, so much smarter. This slide just lays it out perfectly. The old way was like a sports scout just looking at individual player stats. Who's the fastest, who scores the most. But the new idea? It's like a coach on the sidelines asking which group of players working together right now is going to create the perfect play to win the game. It's all about the team, the synergy, not just picking individual stars. So how do they actually pull this off? Well, the researchers came up with this really elegant 2-step strategy they call filter, then wait. It's simple, but it is incredibly powerful. All right, here's how it works. Step 1 is filter. Think of this as building that diverse team. The algorithm quickly scans the data and picks out a set of examples that are not only useful, but also aren't repetitive. You get a good mix. Then comes step 2, wait. Once the team is picked, the algorithm gives each member a precise importance score. By doing this, it crafts the perfect, fine-tuned lesson for the AI to learn from in its very next update. And here's a super important detail. It might seem small, but it's absolutely critical. The weights can only be positive. Why? Because this prevents something the paper calls destructive cancellation. That's when the AI gets mixed signals from data points that are basically pulling it in opposite directions at the same time. By keeping everything positive, you guarantee the lesson is always constructive and pulling in the same direction. Okay, the theory is fantastic. It sounds great, but does it actually work in practice? Let's check out the results and see how this new method actually performs. This is where the rubber meets the road. And the results are just wild. Look at this. On a standard language test, training with 100% of the data gets you a score of about 42.5 points. A classic method, tracing, does better, hitting 47 with just 5% of the data. Pretty good. But this new optimizer-aware method, it hits almost 49, and it also uses only 5% of the data. Let that sink in. It gets a better score using 95% less data. That's incredible. And if you're a visual person, this graph makes it crystal clear. That blue line, that's the new method. You can see it just shoots up right from the beginning. It learns way faster. But not only that, it climbs to a higher level of performance overall and just stays there. It is just flat out more efficient and more effective. Let's just put that amazing leap into one last picture. The original model is way down at the bottom, barely registering. Training on all the data gives you a nice boost for sure. But our new method, using just a tiny fraction of that data, doesn't just match it, it blows past it. So this isn't just about saving time and money, it's about getting a fundamentally better result in the end.
So, okay, what does all of this mean? Why does this matter outside of a research lab? What are the real-world implications of being able to train AI this much smarter?
Well, the implications are actually huge. First off, it means more efficient AI, period. We can train these massive models way faster, using way less energy, which is great for the bottom line and for the planet. Second, it makes AI more accessible. You don't need a building-sized supercomputer anymore to work with powerful models. This opens the door for so many more researchers and smaller companies to innovate. And finally, this could just lead to more powerful AI in general. By giving models the perfect curriculum, we might be able to unlock new abilities that were just getting lost in the noise before.
And that leaves us with this really fascinating question to chew on. We've just seen a method where an AI can essentially learn to pick its own best lessons. It's kind of becoming its own teacher. So the question we have to ask ourselves is, what's the next step in that evolution? What happens next?